Hey there, welcome back to my video series about making a bike frame in my garage. If you didn't see my first video on how I designed the frame, be sure and go check it out. In this episode, I'll show you all the tubes and frame parts I'm using for this project, do some prep work on the tubes, and miter the seat tube to fit the bottom bracket shell. If you're interested in following along as I build myself a new frame, be sure and hit like and subscribe. So here are all the tubes and frame parts. I'll go through each of these real quick, and then I'll put a graphic up with detailed specs at the end. First up is a 44mm head tube from Paragon Machine Works. I've used these on multiple frames and really like them because they allow me to run a suspension fork with a tapered head tube while also keeping my mitering simple because it's still a straight tube. I originally planned on a 180mm head tube, but I already had this 185 version, so I decided to use that. The down tube, seat tube, and top tube are all butted tubes I bought from Bicycle Fabrication Supply. If a tube is butted, that means that the wall of the tube is thicker at the ends where they get welded or brazed together, and thinner in the middle of the tube where that extra material isn't needed. The down tube is 38.1 by 179, meaning that it has a diameter of 38.1 millimeters. One end of the tube has a 1 millimeter wall thickness, then it tapers to 0.7 millimeters in the middle, then tapers to 0.9 millimeters at the other end. The top tube is 34.9 by 969, again 34.9 millimeter diameter with a 0.9 end, 0.6 in the middle, and then 0.9 at the other end. And the seat tube is 35 by 1.65 to 0.9. So the 1.65 millimeter end is for the seat cluster, where the top tube, the seat tube, and the seat stays all meet. There's a lot of stress there with all those tubes meeting on the outside of one tube, along with the stresses of the seat post slot and the clamping of the seat post. With all those stresses at the end of the seat tube there, we want that end of the seat tube to have a nice thick wall. I'm using a Paragon Machine Works T47 bottom bracket shell for this bike versus a standard 38.1 millimeter bottom bracket shell. This gives me a little more room to attach the 31.8 millimeter down tube and results in less overlap of the down tube and seat tube. The chainstay yoke is of my own design, but it is heavily influenced by a yoke created by Konga Bicycles in Finland. I've used the Konga yoke in a couple builds and I like them, but they require a lot of brazing to assemble them, and I think they're heavier than they probably need to be. My version is a little bit lighter and it takes less time to braze up. I designed it in Fusion 360, then had a bunch laser cut out of 4.8 millimeter thick 4130. I simply bend them in my vise and braze the three pieces together. The chainstays are just 19 millimeter straight gauge tubes with a 0.9 millimeter wall thickness. Later on, I'll bend these myself with my cheap Amazon tubing bender. I don't have a good way to accurately do the compound miter at the top of the seat stays, so I've always made a seat stay yoke kind of monostay type thing. The seat stay yoke is made from two pieces of 1.2 millimeter wall 4130. The monostay is 22 millimeters in diameter and the bridge is 19 millimeters. I'm using 16 millimeter seat stays, which might be a little on the skinny side, but because of the monostay, they aren't very long, and I'm not opposed to a little bit of flex in the seat stays. I'm using 12 millimeter low mount dropouts from Paragon for this build. This is the first time I've used these dropouts. The only other 12 millimeter through axle dropouts I've used were Paragon rockers. I'll have to be especially careful to get these aligned in the frame correctly since they aren't adjustable and there's no wiggle room when you're using a through axle. The braze-ons came from various places: Paragon Machine Works, Framebuilder Supply, Bicycle Fabrication Supply, and Metal Guru. I especially like this cable port from Metal Guru. I'll use it for my dropper post. It is a little steel braze-on with an aluminum insert. Here are all the specs of the tubes and the frame parts. It's mostly a mix of tubes and parts that I've had around for a while. A couple of these companies have gone out of business or aren't making bike tubes anymore. The straight gauge tubing for the seat stay monostay is from Aircraft Spruce, which is an aircraft supply company. Other than bikes, homemade aircraft are another common use for thin wall 4130 tubing. I'm always a little tentative about riding a mountain bike that I built myself in my garage, but I can't imagine flying a plane that I built myself. Now it's time to mark the butts on the tubes. This is another frame building specific tool that I bought a few years ago. Relatively inexpensive and much better than the way I checked butts for the first couple frames. Before I got this tool, I would clean the inside of the tube, hold the tube toward a light source, and look down the inside of the tube. When you do this, you'll see the tapered sections because they reflect the light differently or they have a different surface finish. I would then use an old spoke as a sort of dipstick to estimate the distance from the end of the tube to the start of the taper. A butt checker, like this one from Far Frameworks, is much quicker and much more accurate. Like I said earlier, the main tubes are all butted tubes, and to prevent from cutting the butts too short, I need to locate the butts before I miter the tubes to length. If they were all straight gauge tubes, it wouldn't matter where I make the cut. Before I mark the center lines, I quickly check the tubes for major bows. If they have a noticeable bow in them, I want to orientate that bow along the center line of the main triangle. Once I've checked for any major bows in the tubes and marked the butts, I need to mark center lines on the main tubes. This will help locate the miter templates and the tube blocks. I want the center line of the seat tube and down tube to be on the inside of the frame to help in placing water bottle bosses, cable stops, cable guides, stuff like that. Once I have all the reference lines on the main tubes, I can cut the seat tube and miter it to the bottom bracket shell. Another nice feature of BikeCAD Pro is that I can print out miter templates. For my BikeCAD plan, I know that it is roughly 535 millimeters from the top of the bottom bracket shell to the top of the seat tube. So I want to place the miter template on the 0.9 millimeter end of the seat tube with the shoulder of the miter at 535 millimeters. So once I have the miter template in place, I take a Sharpie and mark the edge of the miter. Then I do a rough cut of the miter with a cutoff wheel on a Dremel rotary tool. Then I smooth everything out and get it close to the final miter with a hand file. At this point I put a tube block on the tube. The block serves as a reference for the miter so that everything is correctly aligned. This is especially important for the down tube and top tube since there are miters on both ends of the tube and you don't want those miters to be out of line. So this is my miter finisher. It's a wood lathe mounted to my workbench, and mounted in front of the lathe is a cross slide vise mounted on top of a small rotary table. It's a bit finicky, but I get really tight, really accurate miters with it. Using the lathe, I turn down a set of wood cylinders for all the tube sizes that I use. The cylinders are all 1/16 inch undersized to account for the emery cloth that gets wrapped around them. For some of the smaller tube blocks, I do have to use some shims in the vise to get the tube to the correct height. After the miter finisher, I check to make sure that the miter is square to the tube. And I make sure that the miter is nice and tight on the bottom bracket shell and that the shell doesn't wobble at all. And lastly, a quick check with my digital angle gauge. Everything looks great. There I have it. First miter is done. In the next video, I'll miter both ends of the down tube, drill some vent holes for the main triangle, then lay out and drill the holes for the bottle bosses and dropper port. If you're interested in following along as I continue building myself a bike frame, hit the like and subscribe buttons so you'll see the new video when it comes out in a couple weeks. As the project moves along and my garage gets warmer, I'll try and post more frequently. If you know someone that might like this video, be sure and share it. Thanks for watching, take care, see you next time.